Hello students, this is Miss Dalton and this is the first video in our Unit 12 unit over radical functions. This is about the square root function. So we have the square root function, which is f of x equals the square root of x. One thing I want you to realize is that the square root function is the inverse of the quadratic function. So we're going to take what's in this table over here and we're going to fill in the y values. So what we're going to do here is we're going to start with this x value of -4. If I plug that in for x and I take the square root of a -4, that's going to give us a non-real solution. So since this is a real number coordinate grid, we're only going to be able to graph real numbers, and so any of these negative numbers are going to give us non-real answers. So we're not going to include those at all. When you take the square root of 0, the square root of 0 is 0. When you take the square root of 1, the square root of 1 is 1. And when you take the square root of 4, it's 2. And when you take the square root of 9, that's 3. So graphing the square root function is going to look like this. We're going to have 0, 0. We're going to have 1, 1. We're going to have 4, 2. And we're going to have 9, 3. So it's kind of going to just look like this. It's going to be a curve that starts at the origin. So what do you notice about what you filled into the table? Well, hopefully you notice that you're only going to be able to use positive x values. Okay, what would be the domain for this graph? Well, because the least x value is at 0 and the highest x value goes on forever, then we could say, if we write this in interval notation, this would be 0, infinity. The range, the least y value is 0, and the highest y value, this arrow is going to keep going up gradually. It's going to be a very slow process, but it is going to keep going up. So the range for this is also 0, infinity. So also you need to recall the transformations. Now when we have the square root function, we have a transformation that's going to occur with the a. We're also going to have a transformation with a number getting added or subtracted onto the x under the radical. And then we also have this value at the end here if something gets added or subtracted onto the end. Now, these follow the same transformations that we've used all year. So the a value, if a is less than 0, meaning that it's negative, that's going to make it reflect over the x-axis. So this should not be new. These are all the same thing that we've used for every function that we've studied so far. If the absolute value of a is greater than 1, then it's going to be a vertical stretch. And if a is less than 1, it's going to be a vertical compression. Okay, the h value, if the h is positive, it's going to shift left, because remember, it's the opposite of what you think. And then if it's a minus, actually, let me rewrite this. So it's going to shift left or right. And let me just put this above it. So if it's positive, it's going to shift left. If it's minus, it's going to move to the right. And then for the k value, that's going to make it shift up and down and positive would make it move up, and minus would make it move down. So these are all things that we've learned before, so just make sure you remember those. Okay, as we start to look at the transformed square roots, when you are graphing a square root function, the point HK is going to be your starting point. And then you're going to use your table to list two other points that are not decimals or fractions. So always start with your HK. So let's look at these examples. So we're going to graph the following square root functions and describe how they transform from the parent function. So right now, my H is -1, because remember, we're going to use the opposite. And your K value is 3. Okay, so we're going to start there. So at -1, 3, that's going to be your very first point. Now you want to pick values on the right side of that point. So let's also pick 0. If I plug in a 0, that's going to be 0 plus 1, which is 1. Then I would take the square root of 1, which is 1, multiply that by -2, which is -2, and then -2 plus 3 would be 1. So I would also have a point at 0, 1. And hopefully you're recognizing that this is going to open down, which kind of makes sense because we have a negative out front. That means we are going to reflect. Okay, let's also pick a value, but I want to pick a value that I can actually take the square root of. Because if I look at what's under my radical here, I have something plus 1. Well, remember, the next thing that I could take the square root of would be 4. Well, what value of x would give me a 4 under the radical? Well, I need this x to be 3, so that when I do 3 plus 1, I get the square root of 4. So let's go ahead and put a 3 in for x, and now let's figure out what that is. Well, the square root of 4 would be 2. 2 times -2 is -4. -4 plus 3 is -1. So that's going to give you the point 3, -1, which is right here. Okay, so let's go ahead and connect those dots. Tried to connect them as best I could, and so that's going to be what this looks like. Now, what's the domain? Well, the domain, the least value, is at -1, so it's -1, and it does go to the right, so it's going to be positive infinity, right? Because it's going to go on forever. Now my range, what is the y value of this starting point? The y value is 3, and that's going to be my highest point. So it's going to go from -infinity to 3. And then what are the transformations? Well, first off, with the negative out front, that's going to make it reflect over the x-axis. And then the 2 is going to make it vertically stretch. And the plus 1 is going to make it shift left. Oops. And it's also going to shift up 3. Okay, you go ahead and try this next one on your own. So pick, first start with your H and K, and then pick 2 points to the right of that to figure out 2 more points. When you're ready to check it, go ahead and press play. Okay, go ahead and check your work for part B. Notice that once I write down what my HK is, I'm going to pick values to plug in for x that will give me perfect squares. So I'm going to pick a value of x that will give me 1, right? Because I can take the square root of 1. And then I'm also going to pick an x value that will give me the square root of 4. And so that's why I chose 0 and 3. Those are not the only values that you can choose. However, if you choose something other than those values, you'll get decimals, and so it'll make it harder to graph by hand. Okay, so let's move on to C, and I'm going to go ahead and do this one with you. So the HK, because I have nothing being added on to the end here, the H is 0 and the K is 1. Now, the square root of x, so I'm going to pick the next x value of 1, so that when I plug it in, I'm doing the square root of 1, and the square root of 1 is 1. Then I'm going to multiply that by 2, which becomes 2. And then I'm going to add 1, so that's going to give me 3. So again, I'm plugging in 1, so I'm going to take the square root of 1, multiply it by 2, and then add 1. The next value that I'm going to choose is 4, because I can take the square root of 4. So that would be 2 times the square root of 4 plus 1. Well, the square root of 4 is 2. 2 times 2 is 4. 4 plus 1 is 5. So I'm going to have these points 0, 1, 1, 3, and 4, 5. The domain is 0 to infinity. The lowest y value is 1, so that's going to be 1 to infinity. The transformations, it is a vertical stretch by 2, and it has moved up 1. Okay, now you can write the domain based on just looking at the equation without graphing it. And so one way to do this is you need to keep in mind that you can only take the square root of positive numbers as well as 0, right? So we can only take the square root of positive numbers as well as 0. And so since 0 is the smallest number that we can take the square root of, and a square root function is defined for any number greater than or equal to 0, then to find the domain, we can write an inequality where whatever is under the square root has to be greater than or equal to 0. So here's how you would do this. If I look at the equation in part A, f of x equals the square root of x plus 1, well, we know that whatever is under the radical, x plus 1, has to be greater than or equal to 0. And so when we solve this for x, we would subtract 1 from both sides. Therefore, x has to be greater than or equal to -1. Now, this is an okay way to write domain, right? We don't have to write it in interval notation. It's just that sometimes it's easier. But this is an okay way to write domain as well as an inequality. So if we look at part B, what is the domain for part B? Well, you just have to look at what's under the square root. We don't care about what's around the square root, just what's under the square root. And we're going to set that greater than or equal to 0. There's no solving that needs to be done here, so this is what your domain is. If I look at part C, take what's under the radical, x minus 3, and set it greater than or equal to 0 and see what x has to be. So we would add 3 to both sides. X is greater than or equal to 3, and so that would be our domain. Same thing here. Take what's under the radical, put it greater than or equal to 0, and now solve it. So I would subtract 9. 3x is greater than or equal to -9, and then I would divide by 3. So x is greater than or equal to -3, and that would be your domain. Okay, lastly, let's look at this example. It says use the given function f of x equals negative square root of x minus 1 minus 3 to write a new function with the given transformations. So we want to take that function right here and we want to move it right 1 and up 2. Now, when we move it to the right 1, we're going to have to take what's inside the radical and we're going to have to subtract 1, because remember, it does the opposite. And then we're going to have to add 2 to make it go up. We're going to add 2 to the k. So that means we're going to subtract 1 here, and we're going to add 2 here. Okay, so what would the new value, the new equation be? So we'd have f of x equals negative square root. If we have minus 1 and then another minus 1, that would become x minus 2. And then we have negative 3 plus 2, which would be a minus 1. So that would be the first one. All right, let's go ahead and erase this. And now let's see what we have to add to the next one. So this, we want it to reflect over the x-axis. So that means we would change the negative to a positive. And then we want to make it move to the left 3. Remember, left and right are opposite of what you think. So left would actually be a plus 3. We're going to add 3 to this number right here. So we're going to have f of x equals, it's not going to be negative anymore, it's going to be positive, square root of x, and then negative 1 plus 3 is plus 2, and then we'd have the minus 3 on the end. So this would be our function. Okay, let's look at the next one. And I'm going to go ahead and erase this. So let's make it vertically compressed by 3/4 and a reflection over the x-axis. So reflect is going to change it to a positive, but if it gets compressed, we're also going to put a 3/4 right here. And then it moves to the right 7. Well, that's going to be a minus 7 right here. And then up 8 is going to move up 8 here. So we're going to have f of x equals 3/4 square root. We're going to have x minus 8. And then negative 3 plus 8 will be plus 5. And that would be our function. All right, for this last one, go ahead and try that one on your own. And when you're ready to check your answer, press play. All right, check your answer. This is what you should have gotten. For it to be a vertical stretch by 5, that's going to have a 5 here at the beginning. When it reflects over the x-axis, that's going to change this to a plus, and then make it move to the right 7. You're going to subtract 7 here, and make it move up 8 would be plus 8 here. So the end pieces should be the same as the previous problem, but you'll have f of x equals 5 times the square root of x minus 8. And then plus 5. All right, make sure your notes are filled out, and let me know if you have questions.